Okay, so we're going to be working on definite integrals. And this question asks us to evaluate the integral, the following integrals. So this, let me just label it for you, is a definite integral. And it comes from the Riemann sums formula. So let me just write the formula down for you. Limit as n goes to infinity, sum of I equals 1, n, f x I delta xi. So this is the Riemann sums formula. So let me just write that down here. And you guys probably recall this from your classes. You guys might have done a lesson on it where you find the area underneath a curve or any shape for that matter of a function. So you would use this. So today I'm going to be showing you how to solve this graphically and algebraically. So to begin with, let's just draw a graph, and it doesn't have to be specific, so we don't have to label any points except the 1 and the -1, because these represent our interval of the function, right? The interval in which the function is going to be observed under, right? So let me show you what that means. So I'm going to draw a graph here, like that. And so this is our origin, 0, 0. This will be -1, and this is 1, right? So those are your intervals. And I'll just draw a line with a different color. So I might use orange to just differentiate that is our interval, so you can see it clearly. Right here. Okay. And I know that the line is not completely straight, but we'll just have to work with that. So our function is x cubed, right? And you might already know what that looks like, just to kind of draw it out. So an x cubed graph looks something like this, right? And I kind of drew this close to the line, but let's just pretend like it's fine. So basically, you might already see a shape here, right? You could see a triangle forming over here. So let me just outline that for you. That triangle formed, right? And the same with this. Sorry, that's supposed to be straight. A triangle kind of formed, right? So that is what happened with the x cubed function. Now what we would do next from here is basically you would take the area of a triangle, our triangle, which is 1/2 base times height of this, and the same with this as well, right? So 1/2 base times height. And what you would do is first find the base. So that's pretty easy. We started from 0 and we went to 1, so the base is 1 here. Same here as well. We started from 0, and we went to 1, so that's also 1. But let's look at this first. So 1/2 base would be 1. H is going to be our f of 1, right? So h is going to be our f of 1. Now, how do we find that? Well, basically, we just plug this back into our x cubed function. So 1 cubed is just equal to 1, sorry. And so 1/2 times 1 times another 1 is just going to equal 1/2, right? Now, looking at this, we found that we have 1/2 here. Base we found is 1. F of 1 is also 1. However, this is going to be negative because, as you can see, it goes in this direction. So it's going to be a negative 1/2, right? So when we put that together, 1/2 minus 1/2 equals 0, right? So that is going to be our answer. Let me just circle that in a different color. That's how we solve it graphically. Now, algebraically, it might be a little easier. So let's take a look at this. So the problem, looking back, was evaluate the integral 1 on the top, -1, x cubed dx. And again, these are our intervals. So this is the upper limit and this is the -1 is the lower one, right? So to solve this algebraically, all you're gonna have to do is work backwards. Now, from your classes, you might remember that this symbol also means that you find the antiderivative of the function, right? So first, we're gonna have to find the antiderivative of x cubed. Now, how do we do that? Well, you might already know this. So we're going to have 1/4, because 3 plus 1 is going to be 4. And when that 4 comes down, it's going to have to cancel out. And now how does that cancel out? Well, we're gonna have to have a 1/4. So I'll just write it down for you and then we'll work from there. So we have 1/4 x to the 4th. So if we were to work backwards, I'll use a different color. You'll see that we would if we were to work backwards, say that this was our original function. If we were to work that way, we would go from 4, we would subtract 1. So let me just write that here. 1/4 x to the 4th. If we were to work backwards, we would subtract this. So we would have 1, right? However, before we do that, this would come down. So it would be 4 times 1/4 x, 4 minus 1, which is a 3. This would cancel out, and you would be left with 1x to the 3rd power. Basically, you don't even have to write the 1, so that would just be x to the 3rd. So that's how we got our antiderivative. Now, 1/4 x to the 4th, that's what we have as our antiderivative. From there, also, I'll write down plus c, right? But you may already know that the c cancels out, but I'll just write that down for now, just in case, just to see how the process works and why it cancels out, to better understand. So 1/4 x to the 4th plus c, that's our antiderivative that we got from x cubed, right? And then we want to draw a line, right? Because we're going to be solving for the intervals here. So at the top we have x equals 1, and in the bottom we have x equals -1. And then from there, we would just plug it in. So we would have 1/4, 1. You have to plug in the top value first, to the 4th power, plus c, minus 1/4 -1 to the 4th power, plus c, right? And you can see now that the c's cancel out, right? So that's what happens there. So you don't even have to write down the c part when you do the definite integrals, but I'm just showing it to you just to see what happens to that. So then we're going to be left with 1/4 times 1 to the 4th power, which is just going to be 1 to the 4th power is just 1, times 1/4 is 1/4, minus -1 to the 4th power, that's going to be +1 because this is an even power, so this will just be positive. +1 times 1/4 is going to be 1/4. 1/4 minus 1/4 is equal to 0. So let me just highlight that in a different color. And as you saw, algebraically, we got the same answer as we did graphically right here. Hope that helps.